Hello everybody. So today what we're going to be doing is discussing a mathematical problem. Take it that the part of the leaf which is missing accounts for about 2090 molecules. So this is a hypothetical question in which the molecules lost are in number 2090. My question is, give me the number of integers which add up to make this 4-digit number. You might say that there's so many possibilities that it's not really practical to be doing this in a limited amount of time. However, even if it was, it's definitely not the easiest way to go about such a situation. And so, more often than not, in these types of cases, you will be introduced to a condition. A condition is essentially a second requirement of the question, which allows us to kind of weed out all the unnecessary answers in order that we reach the one required by the question. And so my condition is that those same integers which add up to give us 2090 need to multiply together to give us the single digit number 2. And you might not realize, but I have made this question a whole lot easier. And so try this out on your own, and when you're done, we will try to unravel this question together. So the first thing we need to do is try to figure out which integers multiply to give us 2, because that's the easier part of the question. Well, we know that 2 is a prime factor, meaning it doesn't appear in any other table but its own, and of course 1's table. And so 2 times 1 is 2, and you can say it the other way around, 1 times 2 is 2. And so we know that 1 and 2 are the only numbers we can use to make 2090. And how will we determine how many of each we can use? Well, we know that 2 can only come as a product 2 if it stays only 1 time. That means if we do 2 times 2, that'll give us 4. 2 times 2 times 2, that'll give us 8. And that's already above our condition, which is that the product needs to equal to 2. So we can only limit the use of 2 to 1 time, but we can increase the number of 1's because 1 has the quality of remaining the same no matter how many times you multiply it by itself. And so we can add more 1's. Actually, we'll add 2088 1's. So 1 plus 1 plus 1 onto 2088. And then we'll just add our 2 in there, giving us 2090. Now that we have essentially satisfied both of these conditions, we come to the real question. How many integers did it take? Well, you might think they were 2090 or 2090 integers, but if you did think so, that would be wrong. Why? Well, because we know that we used 1 2088 times. However, after that we used just 1, 2. And 2 is just one integer. That means that in reality we just used 2089 or 2089 integers.